Today we will discuss about another important step, which is basically a very important step in this powder metallurgy process, and this is called compaction. So after this powder you have mixed, and then you have poured into the die cavity with the help of some powder feeder. The next step is to press the powder, and pressing this powder under a predefined load and at a specified pressing speed is known as the compaction. So as you can see from this figure that we have this compaction, this step, and which is occurring in different stages. So in the first step, you have this die cavity, and you have upper punch and you have also lower punch. Then there is a powder feeder, or this is a powder feeding shoe, which basically brings all the powder particles along with it, and then it fills the cavity which is present in the die. And in the next step, this goes back, and then your upper punch and your lower punch compresses the powder material inside the die cavity, and then achieving the required compaction pressure. It is stayed for few seconds, and then in the last stage the upper punch is retracted back, and the lower punch basically it moves upward in order to eject the compacted solid mass out of the die cavity. And this is the first cycle, and in the just at the start of the second cycle, again your powder feeder comes from this side, and then it displaces the this solid compact out of the compaction area. Okay, and if we see at the microstructure level or at the micro level, we will find that initially at the stage one, whenever these powder particles are at a distance, are at some different places inside the die cavity. And in this figure, you can see that if you increase the compaction pressure, initially, suppose if the apparent density, if the density of the powder particle or filled inside the die cavity is 50%, then gradually at stage one, and if you progress up to stage two and stage three, there is a variation in the density, and you are approaching the true density, but it is not possible to get the true density in the compaction stage. So for different powders, different powder materials, you have a different range of compaction pressure as given in this table. So for this aluminium alloy and aluminium powder metal, you have a compaction pressure range of 70 to 275 megapascal, and for brass it is ranges from 400 to 700 megapascal, and then for iron it is 350 to 800 megapascal. And similarly for the different ceramic materials like aluminium oxide, like carbon, like cemented carbides and ferrites, you have this powder compaction ranges, and under which your powder can be easily compacted, and then you can also achieve 80 to 90% of the theoretical density. So the part which is obtained after this compaction stage, it is known as the green compact. So why I'm calling it as a green compact? Green compact means it is a raw material. It is in the raw form. So it has not acquired its actual strength, and it has not acquired its actual density, or you can say the proper density. And also some binder is still inside this powder in this compacted part. That's why I'm referring this press part as the green compact. Now, what are the tools and the equipments which are necessary for compacting the powder material into the die cavity? So we have first of all we require a die and a punch. So die and punch are generally made up of tool and die material, and these are high carbon, high chromium die steel. and you prepare the die cavity as per the required dimension and required shape of the product which you want to obtain after this process. And then you require a press which is necessary to create the required pressure in the die cavity. So you have different types of presses, and mainly there are two types which are used for the commercial, for the industrial applications, and even also for the research applications. These are two types. One is the mechanical type, and another other is the hydraulic type. So this figure shows you this is a big mechanical press of very high tonnage capacity, and at the right side you will find that there is a big flywheel. So so in this press, this flywheel stores the energy, and then suddenly it releases the energy, and it transfers the energy or the compaction pressure by using a variety of mechanisms to the main slide. So this is basically our this particular central cylinder is our main slide to which your punch is attached, and this one is your machine base to which your die is connected, or your die is placed. And this small shoe shape like feature is your powder feeding shoes, and through it your powder flows inside the die cavity. So this is a mechanical press, and this is favorable for mass production. This is basically favorable for mass production, and whenever you don't have much variation in the product shape and size, and you have a routine job to do in your day-to-day life, so this mechanical press is very you can say is cost effective, and it is very good for a particular application. And the limitation is that it's very difficult to control the tonnage or the compaction pressure. So you have to set it using different mechanism, and there is a computer system, and there is a you can say you don't have much freedom on the compaction cycle and compaction load. It's very difficult to set the compaction load as well as the rate at which the compaction pressure is applied, and ejection and all the things are it's difficult to maintain, and gradual compaction pressure is not obtained easily in this mechanical press. Therefore, we have another type of press which is called hydraulic press, and it produces the working force with the application of the fluid pressure. Then you can see here in this case that you have a central sliding, you can say that this is the main slide, and its movement is controlled with the help of this hydraulic power pack, which is filled with the hydraulic oil of a specified grade. And there in this particular hydraulic power pack you have a big hydraulic pump which is used to create the necessary pressure in this hydraulic fluid, and this pressure, or you can say the hydraulic fluid, is transferred into this top reservoir which is having the required pressure. And through this top you can say this top hydraulic arrangement, the necessary pressure is applied or the transferred to this main slide. So, as we have already studied in our previous slide, that the compaction pressure typically ranges from 70 MPa for the aluminium powder, which is a soft and ductile material, and 700 MPa for iron and steel powder, which are of high strength material. Okay, and the required force for pressing depends upon the projected area of the powder metallurgy part. And what is this projected area? This is the area which is present in the horizontal plane for a vertical press. And then you multiply this area by the compaction pressure, it will gives you the required force which is required to press the metal powder into the die cavity. So, if you like the video, then please subscribe to my channel, share it with your friends, and don't forget to hit the bell icon for the latest updates. Thanks for watching my videos.